Good morning everyone, welcome to Swapna physics classes. I hope my audio and video is clear. And somebody asked me to clear this potential energy formula. In our last class we had found that the potential energy is negative, not positive. How we get the negative potential energy? Somebody asked me to clear that out. So I'm going to explain this once again. Then after we will start our today's topic. Okay. And as we know that the work done is the scalar product of force and displacement. Here I am taking a source charge which is nothing but a nucleus which is of a positive charge, and I am taking a test charge which is a electron. The distance between these two charges is r. I just want to bring this test charge to infinity. I just want to bring this test charge to infinity. See, as these charges are unlike charges, both the charges are unlike charges, therefore we will have an attractive force between these two charges. So the direction of force is this one. Okay, therefore this force is towards left hand side. Towards left hand side we will take the negative sign, and towards right hand side we will take the positive sign. Therefore here, according to Coulomb's force of attraction, the force will be equal to minus 1 by 4 pi epsilon naught into Z E square by R square. Okay, Z E into E will be Z E square by R square, where R is the distance between these two charges. Okay, and as per the work done formula, I just want to find out the total work done. Here I am displacing the electron to infinity distance from the source charge Q, that is a nucleus. The charge on the nucleus is Ze. Here I am displacing through small displacement. I am bringing the charge E from distance r to infinity slowly. That means without any acceleration. Here acceleration will be equal to 0. Without any acceleration, I am just moving this charge to infinity slowly. Okay, so initially I am finding out the work done for small displacement dr. Okay, for small displacement dr we have small work done dw. To find out the total work done, I have to integrate this formula. Okay, see here I am applying the force in opposite direction to the attractive force. Therefore here work done is negative. So integration of dw will be w, okay, which is equal to minus, here work done is negative, into integral of f dot dr. Okay, and work done is equal to minus integral of minus 1 by 4 pi epsilon naught Z E square by R square into dr. I just substituted this force, Coulombic force of attraction, in this equation. Therefore work done will be equal to 1 by 4 pi epsilon naught is common, Z E square is common, minus into minus is plus. Therefore Z E square by 4 pi epsilon naught integral of R square dr, and the limits are from r to infinity. The limits are from r to infinity. Okay, if you integrate this, see this is 1 by r square, right? So if you integrate this, therefore we will have the work done formula is Zg square by 4 pi epsilon naught into r minus 1 by r. Integer of minus 1 by r square, integration of 1 by r square is minus 1 by r. Okay, this work done is stored in the form of potential energy. This is the potential energy. Here we have minus sign. Is your doubt clear? Good morning everyone. Good morning Sairam. Thank you for coming to my live. Good morning Rizwana. Good morning Rajesh. Thank you so much for coming to my live. So in this way we had found out the potential energy of an electron which is revolving in an orbit. that too in a circular orbit. The electron is revolving in a circular orbit with velocity v. Okay, and I hope your doubt is clear. In today's class, we are going to discuss about the topic correction for finite nuclear mass. So till yesterday's class, we had taken that the nuclear mass is heavier, that is of infinite mass. Nuclear mass is of infinite mass. Okay, and it is fixed at one point in space. Okay, and the electrons are revolving around this nucleus in circular orbits. Okay, these are the conditions we applied to find out the energy equation for nth orbit and velocity and radius equations for nth orbit and also the Rydberg constant. Okay, but we have to make a correction for the Bohr's atomic model by considering that this nuclear is of finite mass and it is also moving. It is not fixed, it is not at rest position. Okay, it is not fixed in space, it is also moving. So as the electron and the nucleus are bonded to each other with the help of the force of attraction, Coulombic force of attraction and the centripetal force, these two charges will revolve around the center of mass. Okay, these two will revolve around the center of mass. Okay, if electron moves in this direction, nucleus will be moves in this direction. Okay, so therefore these will move along the center of mass, about the center of mass with angular velocity omega, right? Yes. If you have any doubt, you can ask me. Nagaraju, good morning. Thank you for coming to my live. Welcome to my live class. Yes. Okay. And I'm considering the mass of this electron as small m. Let's consider the mass of the electron as small m and mass of the nucleus as capital M. And the distance between these two charges, that is electron and the nucleus, is r. If the distance is r and the distance of the electron from the center of mass is x, then what will be the distance of the nucleus from the center of mass? Write a comment. The distance will be equal to r minus x, right? Yeah, I'm changing my pen color. Okay, now what is the angular momentum? L is equal to r cross momentum, that is position vector into momentum, which is equal to r p sine theta, as a theta is equal to 90 degrees. We left with rp. Okay, I had solved this equation in our last class only. So the angular momentum is equal to position vector into the momentum, which is equal to mass into velocity. Here we have angular momentum. Right? So this angular momentum for the electron, as electron is moving about the center of mass. Okay, the angular momentum for this electron is equal to mass into the distance from the center of mass. Okay, mass into center of mass. And for neutron, what is the and for the center of, just a minute. So here the momentum of the electron about the center of mass is equal to mass into velocity. Okay, mass into velocity. And what will be the velocity here? It is omega, right? M omega. Velocity of the electron from the center about the center of mass is omega. What is omega? What is omega? Anybody? I will give some time. About the center of about an axis, if a particle is rotating with the angular velocity omega, then what will be the momentum for this particle, or what will be the velocity? What will be the velocity? I'm just asking you about the velocity, not angular velocity. This is your question. Okay. Yes. See here, this is for electron, and what about the linear momentum now? So as these two charges are moving about this center of mass, or revolving about the center of mass, same, that is about the same point. Therefore, to be a stable system, the angular momentum of this electron must be equal to the angular momentum of the nucleus. Okay, here the angular momentum of the electron is mass into the distance, which is equal to, here mass of the nucleus is m and the distance is r minus x. Okay, from this equation you can find out this x is equal to m into r minus x by small m. Okay, and you can also find out the value of r minus x. How to find out this? Let's see. This is equation number 1, and using the same equation, m into r minus x is equal to mx. Therefore, m into r minus x will be equal to m into, what is the value of x from equation number 1? From equation number 1, we have m into r minus x by m, small m. Okay, small m get cancelled. Therefore, r minus x value will be equal to capital M times of r minus x by capital M. Yeah, this will be equal, right? Yeah, just a minute, sorry. Here we have to find out the value of x and r minus x. Okay, so mx is equal to m into r minus x. Therefore, x is equal to capital M r minus capital M x. Okay, into m. Therefore, you just bring this towards left hand side and you just take the common. You just take x as common, m plus capital M, which is equal to m into r, where this x is equal to m r by small m plus capital M. Okay, and this is equation number. This is equation number 1. You just cross it. Okay, this is equation number 1 and we have equation number 2, and you just substitute equation number 2 in equation number 1. Okay, therefore this m into x, what is the value of x? We have value of x is mr by small m plus capital M, which is equal to capital M times of r minus x. Okay, now you just bring this capital M towards left hand side. Okay, then m into m by capital M into mr by m plus capital M is equal to r minus x. So capital M get cancelled, therefore r minus x is equal to small m into r, small m into r, just multiply divided by m plus capital M. This is equation number 2. This is equation number 2. Okay, here the momentum of the electron is equal to momentum of the nucleus. I consider the momentum of the electron is equal to momentum of the nucleus. And coming to the angular momentum. Coming to the angular momentum of the electron. Did you find out that angular momentum of electron and angular momentum of nucleus? Angular momentum of electron is equal to, as we know that angular momentum is equal to r into p, that is position vector into the momentum, mass into velocity. Here we have omega, that is angular velocity. Okay, so write the equation mv. Here we have angular velocity in place of velocity. That means the relation between velocity and angular velocity is position vector into omega, r omega, v equals to r omega. I asked for this equation only just now. We just substitute in the above equation. Therefore we have what is the distance between the electron and the center of mass? Electron and the center of mass, it is x, right? Therefore you just replace x in place of r. Therefore we have x m into x omega. So therefore the angular momentum of electron is mx square omega. mx square omega. And coming to the angular velocity of the nucleus, we have m into what we have, that means what is the distance between the center of mass and the nucleus? We have r minus x. Okay, therefore r minus x whole square into omega. And this is the linear momentum for, angular momentum, orbital angular momentum for nucleus, and orbital angular momentum for electron. As these charges, both the charges are moving about the center of mass, same center of mass. Okay, the momentum will be same, and to find out the total orbital angular momentum, we have to add up the angular momentum of the electron and the nucleus. Therefore it will be equal to m omega. I am taking m omega common in both these equations. M omega common in both these equations. We left with x square plus r minus x whole square. Okay, now you just substitute the value of x and r minus x. What is the value of x? We have this is m capital M r by small m plus capital M. Capital M r by capital M r by small m plus capital M whole square. Okay, plus this will be small m r by capital M plus small m whole square. Okay, now if you solve this equation, we have the angular momentum as the angular momentum as, see here I'm taking this r square outside, okay, m omega r square by this small m plus capital M whole square, okay, and we left with small m plus capital M, small m plus capital M, okay, and if you cancel out this, I'm taking a fresh page. If we cancel out this, what we left with? Angular momentum is here omega r square. I'm taking omega r square outside. Omega r square outside. We left with m by small m plus capital M. Small m plus capital M. Okay. This I'm considering this. I'm considering this. Did you solve this equation? Did you solve this equation? This will be m capital M r square plus small m square r square. Did you solve this equation? So here we left with okay. Again my system went down, sorry. ఈరోజు టైం బాగాలేనట్టుంది అసలు. ఒకసారి పవర్ కట్ ఉంది. It's not reacting again. My system is not reacting. If you solve the above equation, we have this angular momentum as small m capital M by m plus capital M into r square omega. You just solve that equation. See, I'm not going to solve the complete equations. Step by step అయితే సాల్వ్ చేయట్లేదు, ఎందుకంటే మనకి చాలా తక్కువ టైంలో మనం ఎక్కువ కవర్ చేయాలి. ఓకే, సో ఐఎమ్ కన్సిడరింగ్ this m by m plus m as mu. I'm taking this as mu, okay, which is equal to angular momentum equal to mu r square omega, where mu is a reduced mass. I'm sorry once again for the inconvenience actually, okay. This mu value is equal to m by small m plus capital M. This is a reduced mass. You can also write this equation as yeah, it's enough. So here what happened, the mass is reduced by m by m plus m times. Here if you correct the you have to correct the energy equation, radius equation and velocity equation here. Why? Because here the mass is changed, the mass is reduced because of the nuclear finite mass and the motion of the nucleus. Okay, so therefore we need a correction for energy and radius and for also velocity So therefore what are the equations initially we have for infinitely heavy nucleus? L equals to mbr. For finite nucleus it will be L equals to mu vr. And for initially we have for infinitely heavy nucleus radius equation as n square h square epsilon naught by pi mz e square and for finite nucleus it will be n square h square epsilon naught by pi mu z g square. Here if you relate both these equations, okay, then this radius equation Rn prime by Rn, I just want to divide both these equations to find out the relation between the radius of the nth orbit for finite and infinitely heavy nucleus. Okay, so therefore I have n square h square epsilon naught by pi mu z e square into, I am taking the reciprocal of the radius for infinitely heavy nucleus, m pi m z e square by n square h square epsilon naught. Okay, pi m z e square n square h square epsilon naught. So n square h square epsilon get cancelled, pi cancelled, z square cancel. Therefore this Rn prime will be equal to small m by mu into Rn. This is the relation between the radius of the nth orbit to the radius of the infinitely heavy nucleus. This is the radius for finite nucleus. This is the radius for infinite nucleus for nth orbit. Okay, this is the relation for the radius for finite and infinite heavy nucleus. Okay, and you have to solve for the relations between the velocity of the finite velocity of the electron which is moving in the nth orbit for finite nucleus and velocity of the electron which is moving in the nth orbit for infinitely heavy nucleus, and also for energy equations. You have to find out the relation between these two as well as between these two. This is your work. Okay, this is your work, and I'm just rewriting this equation. In place of mass m, I'm substituting mu. Okay, here Vn is equal to Vn prime. Why? Because there is no mass term in this equation. Okay, and here En prime is equal to minus mu z square e power 4 by 8 n square epsilon square h square. Okay, finally if we do the correction, if we make the correction for finite nucleus, for radius of the nth orbit and energy of the nth orbit, these will be the equations. Okay, yes, and coming to our next topic. These are the relations between mass and the reduced mass. Here mass of the electron is reduced mass ante den mass reduce ayindi ikkada mass of electron is reduced. Sorry for the inconvenience, వీడియో స్టార్ట్ అయినప్పుడు అయితే కాస్త ఇన్కన్వీనియన్స్ అయితే వచ్చింది, ఎందుకంటే పవర్ కట్ ఉండే అంత డిస్టర్బెన్స్ ఉంది నాకు, సో inconvenience అయితే ఉండే. Sorry for that. Okay, these are the relations, very important relations you have to remember. Okay, and coming to the next topic, correction for Rydberg constant. Energy equation correction undi, velocity equation correction చేసాము, radius equation correction చేసాము. Then what about Rydberg constant? In our Rydberg constant also we have mass m, that is mass of the electron, and to find out this equation we had considered that nuclear is of infinite mass కన్సిడర్ చేసి ఈక్వేషన్ ఫైండ్ అవుట్ చేసాం కదా. మరి రెడ్యూస్డ్ మాస్ అంటే మ్యూ ఈక్వల్స్ టు m by m plus m అని రెడ్యూస్డ్ మాస్ ఫైండ్ అవుట్ చేసాం కదా, అంటే ఫైనైట్ న్యూక్లియస్కి. మరి ఫైనైట్ న్యూక్లియస్కి రిడ్బర్గ్ కాన్స్టెంట్ వాల్యూ ఏంటి? సింపుల్గా ఏం చేయండి, m ప్లేస్లో ఫస్ట్ ఫర్ రెడ్యూస్డ్ మాస్ ఐఎమ్ టేకింగ్ ఇట్ యాజ్ క్యాపిటల్ M for reduced mass. This will be equal to mu e power 4 by 8 epsilon naught square h cube c. You just substitute mu value in this equation to find out the Rydberg constant for reduced mass. Okay, therefore this Rm, Rydberg constant for reduced mass, will be equal to m capital M by m plus capital M. Okay, m plus capital M into e power 4 by 8 epsilon naught square h cube c. 8 epsilon naught square h cube c. Okay, now here I'm just writing m. I'm bringing this capital M towards denominator. I'm just bringing this capital M towards denominator, or else you just divide numerator. You just divide numerator. You just multiply and divide the numerator with capital M. Okay, so therefore we have m by m plus capital M by m. Okay, what I did here is I just multiplied with capital M and divided with capital M. Therefore, what we have here, see here, I divided the numerator with capital M and also the numerator and denominator. I just divided the numerator with capital M and also the denominator with capital M. Okay, or else you can also bring this capital M. Here we left with capital M, one more capital M, right? Or else you can also bring this capital M towards denominator. మీకు ఎలా ఇన్కన్వీనియంట్ ఉంటే అలా చేసుకోండి. రెండు మెథడ్స్ కూడా ఒకటే. Therefore e power 4 by 8 epsilon naught square h cube c. Therefore this Rm value can be written as small m by 1 plus m by m. Okay, mm get cancelled. E power 4 by 8 epsilon naught square h cube c. This is the reduced mass equation. Whenever you consider the reduced mass, this will be the Rydberg constant equation. This will be the Rydberg constant equation. Okay, that too for nucleus. Reduced mass, electron mass ఎందుకు రెడ్యూస్ అయిందంటే మనం న్యూక్లియస్ కూడా మూవ్ అవుతుందని కన్సిడర్ చేసాం. ఓకే and next topic is how will you relate the mass of the electron and mass of the heavier nucleus. Okay, from here only you can find out the m by m value. You can, if by considering the m by m value, you can solve for m by m value from the above equation only. M by m, that is for lighter mass and heavier mass. Okay, I'm considering the lighter mass as electron and heavier mass as positive charge. Okay, that means a nucleus. Okay, it will be equal to 1 by 1836. The value will be equal to 1 by 1836. And coming to our next topic, quantum numbers. Good morning Hari, good morning Dinesh. Thank you for joining my love. Coming to quantum numbers, quantum numbers are used for the configuration of the electrons in their orbits. Okay, and we have 4 types of quantum numbers. One is principal quantum numbers, which is denoted with the n. This gives us the energy of the orbits. This gives us the energy of the orbits in which an electron is present. Okay, for example, for hydrogen atom, I'm considering an hydrogen atom, and the energy equation is for nth orbit minus 13.6 by n square electron volts. The energy equation is minus 13.6 by n square electron volts. Okay, and for first orbit n value will be equal to 1, therefore energy is equal to minus 13.6 electron volts. Okay, this principal quantum number which is denoted with n, we take the values from 1 to so on infinity. Okay, this principal quantum number gives us the energy for which the electron is present. Here, if the electron is present in first orbit, that is for n equal to 1, the energy will be minus 13.6 electron volts for that orbit. Okay, and coming to the orbital or azimuthal quantum number. It is denoted with small l. Okay, and this gives us the shape of the orbit. And not only that, here in principal quantum number, for n equals to 1, 2, 3 and so on, this can also be represented as, that means first orbit can be represented with the k, l, m. Second orbit is represented with l. Third orbit is represented with capital M and so on. You can also represent with KLM. Okay, these are nothing but the shells. You can also say it as shells. Orbitals ni shells kuda anochu. Okay, and coming to the orbital or azimuthal quantum number, this gives us the shape of the orbit. For example, I am taking a shell, P subshell, and it will have dumbbell shape. Dumbbell shape ఉంటుంది p orbit కి. ఓకే, అండ్ d orbit కి వచ్చేసి డబుల్ డంబెల్ షేప్ ఉంటుంది. అంటే ఏమవుతుందంటే, ఇప్పుడు మనకి we have a nucleus at the center, and around this nucleus we have the orbits. These orbits might be spherical or elliptical orbits. According to Sommerfeld, the orbitals are of elliptical shape, but according to Bohr, those are of spherical shape. Okay, and this is for n equals to 1, this is for n equals to 2. That means K shell, L shell and so on. In this K shell we are also having subshells కూడా ఉంటాయి. వాటిని ఏమంటాం మనం? S, P, D, F subshells ఉంటాయి. ఓకేనా, and this L can take values from 0, 1, 2, 3 and so on, up to where? n minus 1. Okay, no? So for L equals 1, you will have S subshell, L equals to 1, P, L equals to 2, D subshell, L equals to 3, F subshell, up to n minus 1. For example, I'm writing here the example. So L can take values from 0, 1, 2, 3 and so on, n minus 1. That means you can also represent with S, P, D, F. Okay, subshells n minus 1. Subshells can also be represented with S, P, D, F. These are of small letters. Okay, and for example, for n equals to 3, L can take values from 0 to 3 minus 1. That means L values are 0, 1, 2. Here we have SPD subshells. Okay. and this S subshell will be spherical shape. P subshell will be of a dumbbell shape ఉంటుంది. D subshell double dumbbell shape, double dumbbell shape ఉంటుంది D subshell. Okay, now coming to orbital magnetic quantum number, ML, orbital magnetic quantum number. This gives us the orientation of the orbital, orientation of the orbital. This gives us the orientation of the orbital. For example, P subshell లో మనకి subshells ఇంకా subshells ఉంటాయి, px, py, pz. ఇవి subshells అన్నారు. Actually this P subshell is oriented in the direction of px or py or pz direction. Okay na? We have three coordinate system, Cartesian coordinate system, for example x, y and z axis. Okay, if this P subshell is oriented in px direction, that means this will be the P subshell you are having. Y orientation తీసుకున్నారు అనుకోండి, this will be the orientation. Okay, and z తీసుకున్నారు అనుకోండి, this will be the orientation of this P subshell. Okay, orbital magnetic quantum number gives us the orientation of this orbital. And what about the values? ML can take the values from L to minus L. Okay na? If for example L value is 2, ML value is 2, 1, 0, minus 1, minus 2. Okay, 2, 1, 0, minus 1, minus 2. This is about magnetic quantum number. And for L equals to 2, we have D subshell. Okay, and coming to spin quantum number, before going to explain the spin quantum number, you have to know about the spin of the electron. Spin of the electron is half. Okay, if this electron is clockwise, it will be plus half, otherwise you will have minus half. Okay, if the electron spin is in upward direction, you will have plus half. If it is downward direction, you will have minus half. This spin quantum number take the values of plus or minus s. Okay, electron spin downward direction ఉంటే minus తీసుకుంటాం, and upward direction ఉంటే plus sign తీసుకుంటాం. This is about spin quantum number. Spin quantum number gives us the orientation of the electron. Spin quantum number gives us the orientation of the electron. Welcome Mahesh, good morning. Orientation of the electron, this gives us the orientation of the electron. Yes, and how to fill the electrons in their subshells. You have to consider the increasing order of n plus l values. For example, for n equals to 1, see here I have written 1s square. 1s square nothing but n into l, nl, not into nl. You have to take nl. So I'm not giving the idea of powers. నేను పవర్స్ గురించి ఇక్కడ డిస్కస్ చేయట్లేదు. ఇక్కడ ఫస్ట్ మనం ఏం చేయాలి, ఏ వాల్యూ అంటే 1 years తీసుకోవాలా 2 years తీసుకోవాలా, ఎందుకు 2 years ముందు తీసుకోకూడదు 1 years కన్నా. ఓకే, సో నేను ఇక్కడ ఏం చెప్తున్నా అంటే ఇంక్రీజింగ్ ఆర్డర్ తీసుకోవాలి, n+l వాల్యూ ఇంక్రీజింగ్ ఆర్డర్లో తీసుకోవాలి. ఇక్కడ 1s ఉందనుకోండి, హియర్ దిస్ ఈజ్ ns. సో ns రిప్రజెంటేషన్ తీసుకొని మనం ఎలక్ట్రాన్స్ని ఫిల్అప్ చేయాలి సబ్ షెల్స్లో. ఓకేనా, లెట్స్ సీ. ns రిప్రజెంటేషన్ తీసుకోవాలి అండ్ nl రిప్రజెంటేషన్ తీసుకోవాలి అండ్ n+l చేయాలి మనం. సో ఇక్కడ n వచ్చేసి 1. ఓకే, n+l వాల్యూస్ చూద్దాం. n+l వాల్యూస్, n వచ్చేసి 1. s means what is the value of l for s? It is 0, therefore we have 1. And coming to the next one, that is for 2s. okay, 2 plus s వచ్చేసి 0 కాబట్టి it will be 2. and coming to next one, that is for 2p. 2 plus p value is 1. okay, l value ఏంటి, p కి 1, it is equals to 3. సో ఇలా ఇంక్రీజింగ్ ఆర్డర్లో మనం తీసుకోవాలి. ఇంక్రీజింగ్ ఆర్డర్లో ఎలక్ట్రాన్స్ ఫిల్ చేయాలి ఈ ఆర్బిట్స్లో. అంటే ఫస్ట్ ఏం చేయాలి, మనం 1sలో ఫిల్అప్ చేయాలి, తర్వాత 2sలో ఫిల్అప్ చేయాలి, 2pలో ఫిల్అప్ చేయాలి. ఓకేనా, ఈ పవర్స్ ఏంటంటే మ్యాక్సిమం నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ టు బి ఫిల్డ్ ఇన్ దిస్ రెస్పెక్టివ్ ఆర్బిట్స్. ఈ ఆర్బిట్స్లో మనం మ్యాక్సిమం నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ని ఫిల్అప్ చేస్తూ ఉంటాం అన్నట్టు. ఓకేనా, ఓకే, ఈ ఆర్డర్ కరెక్ట్ అయినా ఒకసారి చెక్ చేయండి. ఈ ఆర్డర్ ఒకసారి కరెక్ట్ అయినా చెక్ చేయండి. ఓకే, మీకు కన్ఫ్యూజ్ అవ్వకుండా ఉండడానికి ఐ విల్ ఎరేజ్ దిస్. ఓకే, ఈ ఆర్డర్ కరెక్ట్ అయినా ఒకసారి చెక్ చేయండి. మీకు ఇక్కడ మిస్టేక్ అనిపిస్తే చెప్పండి. సో దిస్ 4s must be placed here. 4s must be placed in between 3p and 3d. ఒకసారి చెక్ చేయండి. 4s ఇక్కడ ప్లేస్ చేయాలి. ఎందుకు అంటే ఇక్కడ 3p వాల్యూ, 3pకి n+l వాల్యూ ఏమొస్తుంది చెక్ చేయండి ఫస్ట్. n వాల్యూ వచ్చేసి 3 ప్లస్ p వాల్యూ వచ్చేసి 1, ఇట్ విల్ బి ఈక్వల్ టు 4. ఓకేనా, 4s వాల్యూ 4sకి చెక్ చేయండి. 4 ప్లస్ 0 4. ఇక్కడ చెక్ చూడండి, రెండు వాల్యూస్ కూడా సేమ్ ఉన్నాయి మనకి. అంటే రెండింటికి కూడా, రెండు ఆర్బిటల్స్ కూడా n వాల్యూస్ సేమ్ ఉన్నాయి, n+l వాల్యూస్ సేమ్ ఉన్నాయి. మరి ఈ 3p ఫస్ట్ ఉండాలా, 4s ఫస్ట్ ఫిల్అప్ చేయాలి? అంటే 3p ఫస్ట్ ఫిల్అప్ చేయాలా, 4s ఫస్ట్ ఫిల్అప్ చేయాలా? ఆబ్వియస్లీ మనం ఇక్కడ ఏం కన్సిడర్ చేయాలంటే n వాల్యూ దేనికి ఎక్కువగా ఉంటే దానికి ఎనర్జీ ఎక్కువ ఉంటుంది. ఓకేనా, సో మనం ఈ n వాల్యూ ఎక్కువ ఉన్న దానికన్నా ఫస్ట్ తక్కువ ఉన్న దాన్ని ఫిల్అప్ చేయాలి కదా, అవునా? మనం ఏం చేయాలంటే ఫస్ట్ తక్కువ ఉన్నదాన్ని ఫిల్అప్ చేద్దాం, తక్కువ ఎనర్జీ ఉన్నదాన్ని ఫస్ట్ ఫిల్అప్ చేద్దాం. ఓకే, అంటే ఏం చేయాలి, ఫస్ట్ 3s to 3p 6, తర్వాత ఇది కన్సిడర్ చేయాలంటే ఇక్కడ ఎందుకు అంటే ఇక్కడ n వాల్యూ ఏంటి 3 ఉంది అండ్ ఇక్కడ వచ్చేసి n వాల్యూ 4 ఉంది. అంటే దేనికి తక్కువ ఎనర్జీ ఉంటుంది, థర్డ్ ఆర్బిట్కి ఎనర్జీ తక్కువ ఉంటుంది కాబట్టి ఫస్ట్ ఆ ఎనర్జీ లెవెల్ ఆర్బిటల్ ఫిల్అప్ చేసిన తర్వాతకి మనం ఈ 4th ఆర్బిట్ అనేది ఫిల్అప్ చేయాలి ఎలక్ట్రాన్స్తో. ఓకేనా, సో ఈ ఆర్డర్ ఫాలో అవ్వాలి మనం ఎలక్ట్రాన్స్ ఫిల్అప్ చేయడానికి. అండ్ మ్యాక్సిమం నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్, ఎన్ని ఎలక్ట్రాన్స్ ఫిల్అప్ చేయొచ్చు అంటే 2n². రిమెంబర్ దిస్ పాయింట్, మ్యాక్సిమం నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ టు బి ఫిల్డ్, మ్యాక్సిమం నెంబర్ ఆఫ్ electrons to be filled in orbits or shells. In orbits or shells. ఒక షెల్లో మనం ఎన్ని ఎలక్ట్రాన్స్ ఫిల్అప్ చేయొచ్చు, 2n². ఓకేనా, సో ఎగ్జాంపుల్ చూద్దాం. ఐఎమ్ టేకింగ్ Okay, I'm taking 1s orbit. 1s orbit, that means n equals to 1 ki subshell వచ్చేసి 0 subshell ki. Okay, 0 subshell ki maximum number of electrons ఎన్ని ఫిల్అప్ చేయొచ్చు, ఎన్ని ఫిల్అప్ చేయొచ్చు అని చెప్పిన 2n² అంటే సబ్స్టిట్యూట్ చేయండి n వాల్యూని. 2 into 1 square will be 2. Therefore in 1s orbit you can fill with maximum 2 electrons. Okay, and coming to 2s orbital lo any electrons fill up cheyochu. Okay, let's see from this formula 2n square 2 into n value enti ikkada manaki n value 2. Okay, 2 into 2 square will be 8. Okay, maximum number of electrons any fill up cheyochu manam 8. Okay, yes. And coming to 2p next 2p orbit కదా. 2p orbit లో 2n² ఫార్ములా యూజ్ చేసి ఎన్ని ఆర్బిట్స్ ఎన్ని ఎలక్ట్రాన్స్ ఫిల్అప్ చేయొచ్చు, 8 ఎలక్ట్రాన్స్ ఇక్కడ కూడా, ఎందుకంటే n వాల్యూ వచ్చేసి 2 కాబట్టి. సో ఇన్ దిస్ వే యూ కెన్ fill up the 2n² maximum number of electrons in the orbitals. Okay, and in our next class we will discuss the topics. Next topic coupling schemes discuss చేద్దాం నెక్స్ట్ క్లాస్లో. ఈ క్లాస్ అయితే కొంచెం డిస్టర్బ్డ్ గానే ఉంది. గుడ్ మార్నింగ్ అశోక్, గుడ్ మార్నింగ్ ప్రవీణ్, గుడ్ మార్నింగ్ చంద్రరావు. థ్యాంక్ యూ ఫర్ జాయినింగ్ మై లైవ్ క్లాసెస్. ఇప్పటివరకు సబ్స్క్రైబ్ చేసుకున్న వాళ్ళైతే సబ్స్క్రైబ్ చేసుకోండి నా ఛానల్. అండ్ ఈ క్లాస్ అయితే అఫ్ కోర్స్ డెఫినెట్గా డిస్టర్బ్గానే ఉంది. ఐ అగ్రీ విత్ యూ. ఐ హోప్ ఇట్ విల్ నాట్ రిపీట్ ఇన్ అవర్ నెక్స్ట్ క్లాస్. అండ్ థ్యాంక్ యూ ఫర్ జాయినింగ్ మై లైవ్ క్లాసెస్. ఇప్పటివరకు సబ్స్క్రైబ్ చేసుకుని వాళ్ళు సబ్స్క్రైబ్ చేసుకొని నా లెక్చర్ మీకు హెల్ప్ఫుల్గా ఉంటే లైక్ చేయండి, మ్యాక్సిమం నెంబర్ ఆఫ్ పీపుల్తో అయితే షేర్ చేయండి. ఓకే, థ్యాంక్ యూ, బాయ్. I will close this lecture here.